once again. We're now working with parametric equations. This is 6.4. This is kind of mixing your normal algebra with trig. We're going to be graphing things such as 2x's, hyperbolas, and circles. This kind of gives you an idea of what we're doing or why we're doing it. I'll let you read that. Let's get started right away. Get through the material as fast as we can, just so we can do something else. Okay, so we will focus on just rewriting the parametric equation. So we want to do this in the form of single equations on x and y. This is called eliminating the parameter. Eliminating the parameter. Right down the middle, that's where you're going to do it right with the arrow. Eliminating the parameter. So we want to eliminate the parameter and sketch the graph. So the first thing I want to do is solve for cosine t. I want to get whatever my cosine, sine, whatever that is by itself. That way we're just left with like x or y or a number or whatever we get. So right away I'm going to take cosine t. I know that's going to be equal to, cosine t is going to be equal to, remember from the last couple chapters, 2 divided by 3, that's good. That's good. That's 3 up to equals x over 2. Now we want to get the sine t by itself. Same thing, times that squared. So sine t is equal to y over 2. Okay, once we're there, we just want to substitute x over 3 this here in sine t, which is y over 2, into our Saturn identity, which is, if you remember, cosine squared plus sine squared equals 0. Or 1, sorry. Cosine squared plus sine squared equals 1. So I'm going to just write my cosine and my sine as a theta by that. So we have x over 3 squared plus y over 2 squared equals 1. Okay, right away, now we can just take our powers. So we're going to have x squared over 9 and plus y squared over 5. Okay, with this, I'm looking at this and thinking it's kind of like a circle because x squared plus y squared equals 1 is a circle. We have two different elements here. These are going to be what I would say are your vertical rise, which is actually 2 here, and then your horizontal run, which is 3. So right away, we don't have a shift on our x. If it was like x minus 1, we'd have to shift it, or y plus 1, we'd have to shift it up and down. Since we have just this, we're going to take the square root of that 9, or look at our 3, and that's going to tell us how wide we need to be in that direction. So with this question, we know that we have a, what, as I would call it, a lift just because of the formula. It's not a circle because this should be 1 and that is 2. So now I know I'm actually at the origin for my midpoint. Now I look at where I want. Well, that's 4, which is actually 2 before. So that's going to be my rise. And that's all. Okay, so now I look at my x, which is 9 equals 3, which is my y, and this is x. So then that makes me a nice which is like a smash circle in this case, which you can't really see the best from the picture, but that's kind of what let's get to the next one. Okay, now we have x equals 3 plus sine t and y equals cosine t plus minus 2. Once again, we just want to get whatever our trigonometry features are by themselves. So sine t is equal to, sine t is equal to x minus 3. Okay? And then on this side, we have sine theta. So cosine t is equal to y plus 2. Okay? So that's pretty straightforward. Once again, we just plug it into our tangent identity. So we want to plug in cosine, we want to plug this in for cosine and this in for sine. Okay? We have, I'm going to do my x here, so I have x minus 3 squared plus y plus 2 squared equals what? Equals 4. Okay? Now that I have that, I'm going to look at this and think, I have a circle here. The only difference, or the only reason I know that is because if you think about it, this is all over 1. Don't doesn't elongate it or make it smaller. It's just, you're going to have the same radius, which is going to be 1 over the entire figure. Well, we have a horizontal shift and a vertical shift when it comes to where our origin is. So I'm going to go over here. Now I know I need to go, instead of x minus 3. But when we're saying x minus 3, that's really saying we need to go plus 2. And then y plus 2, that's really saying we already have a 2. So that's fine. So now I know that our radiuses are 1. So I'm just going to make my mark all around 1. And then I'm kind of guessing now where my circle is. So we change colors a little bit. You see there. And then you kind of estimate at where your circle will be. So remember, our radius or our distances from the center. So that's kind of what we're looking at. The next question is going to be the deuces. This is where it gets a little bit more difficult in understanding what we're doing. Once again, we want to get whatever we have, the secant and tangent, by itself. So now we have, so I'm going to do this kind of a long way so you can see how it's done. X equals, let's do, subtract 3 from this one, and get 2 from this one. So we have x minus 3 equals 2 secant t, and the other one is y minus 2 is equal to 4 tangent. Well, I'm going to get these still by themselves. So my next step is to divide that 4 out of there. Convert the 200. 2, 4. The secant t is equal to x minus 3 over 2. And then tangent t is equal to y minus 2 over 4. And once again, we're just taking what we know, but this time we have secant and tangent. So really, we want to look at our formula sheet, and we know that 1 plus tangent squared x is equal to secant squared. Which, that could be a key or an x, either way, however you want to look at it. So we just plug what we found into those spots. So we have 1 plus tangent squared, so we have y minus 2 squared, y minus 2 over 4 squared, which is equal to now secant, which is x minus 3 over 2 squared. Okay, this isn't really what we've been working with. We want to get that 1 by itself on the outside. So what I'm going to do is subtract this term over. I'm going to subtract y minus 2 over 4 squared, y minus 2 over 4 squared. So that's going to leave me with, I'm just going to write this term first. minus 3 over 2 squared minus y is 2 over 4 squared. Okay, this is a little bit different than what we were working with before. As you can see, we have a negative sign here instead of a plus. So that's going to tell us that this, like I said, it's going to be a little different than what we've been working with. So now we need to look at what type of answer, what type of thing we're going to draw. In this, when you have a function that looks similar to this, it's going to be a hyperbola. Hyperbola. So write that. Hyperbola. So a lot of you are like, hyperbola, that's fancy word. That's where you have two things that kind of look like that. They don't cross a certain path as a center or a focal point. Well, we need to find that focal point and where the asymptotes are. Which are what they are now. First thing we want to do is look at our x and our y. Look at x minus 3, so really we're shifting over 3 to the right. Not to the left, to the right. Now we want to go up 2, not down 2, up 2. So that's going to be our center. So kind of like in our picture over here, that's going to be our center. Okay, so now we need to think, okay, well, how do I make the asymptote? Well, all that is taking your quantities from your original equation, right? First here, I'll say that. This one right here. Okay, that is how the distances we're going to go out from our main point right here. So we know that x, we go horizontal 2. And then we go vertical 4. Well, if you kind of see, we made a little box. But, anyways, once you have that box, the key is, if you connect the corners of your box through the center, that's kind of creating a natural, as I would call it, asymptote. That's what you want. Which if you wanted the actual formula for that, that one was right. I'm going to write that. That's pretty evident. Mr. K, what are you doing? That's already before. So if I take this, that's what I have. Okay, so we're looking here at that. We rose 4 and we went over 2. So we rose 4 and over 2. Look at that. Over 2. Now we need to go the other way, which is again the same slope, but instead of being positive, it's going to be negative. And a lot of you are like, oh man, this is getting pretty crazy. All that's from, we have a up 4 over 2. Look over here. It's just before below your y, so you're running 4. And you're rising 4 and you're running 2. That's how you find your asymptote. Okay? Now the question is our hyperbola like the one I drew over here? Or is it like this? We have a box. Like that. Well, the best way to tell is to take your same numbers and then go up to the opposite direction. Up to, and I'm going to go 4. Because our points here and here are not inside the box, so that's where our hyperbola is. Once we know that, we know that drawing hyperbola, we're going to be hitting this point right here. So it's kind of like you're just drawing a little punctuate up like that, a little punctuate up like that. Same thing on this side. You're going to hit that point, go up, and go up. Okay? So once again, our asymptotes were found by 4/2 equals 3. And then the other one was it's just going to be the opposite slope, like that. Negative. Okay, so here's we go down 4 and around 2. Is there any questions about that? I know that's a pretty difficult question. There's a lot going on. Write your question and good questions, Doc, please. I'd be more than happy to try and answer some or talk or create discussion. So please write me a good summary and answer your questions. There's your assignment.